Hi everyone, welcome to the Industrial EcoDistricts webinar. We're going to wait a few more minutes to get started to let a few more people join. Okay, let's go ahead and get started. I know a few people are still joining, but don't want to start too late. So welcome everyone. This is the Industrial EcoDistricts webinar. My name is Naomi Cole. I'm the Director of Certification and Innovation for EcoDistricts, and I'm here with Jen McGraw and Scott from the Center for Neighborhood Technology, who are going to be your primary presenters today. We are pleased to host this webinar, which is part of an ongoing series of topical presentations that we deliver with our members and partners. So thank you for joining us. So our agenda for today is going to be a quick introduction to EcoDistricts and our work, and then the bulk of the presentation is going to be based on research that Scott and Jen have done on industrial ecodistricts, the why industrial ecodistricts matter, and then key best practices, which is what I imagine you are all most interested in. And then we've planned a good amount of time for Q&A and discussion, so I encourage you to be thinking about your questions as you hear from Scott and Jen, so we can have a healthy conversation after you hear from them. And then we'll have a few minutes of wrap up. Couple logistical things. We are recording this webinar and it will be posted online on our website within a week. Attendees will be in listen-only mode, but please submit your questions at any point and I will be collecting them and asking them of Jen and Scott once they're done with their presentation. So first, a little bit about our organization and why we do this work. So EcoDistricts is a 501c3 based in Portland, Oregon, and we are really driven by the value that everyone deserves a great neighborhood. Our mission and our work is about advancing a new model for neighborhood development, and I'll tell you a little bit about what that looks like and how we work. So we have four sort of major threads to our work. The first one is community, which is really about building the market for this kind of sustainable neighborhood development work. We do training and professional development. We have an annual EcoDistricts conference in the fall. We do an EcoDistricts incubator, which is a 3-day training program for project teams. We have a couple-day workshop on district energy and water every year, in addition to other day-long trainings and workshops that we do. This is really about advancing, again, advancing kind of the market for leading projects and practitioners who are involved in eco-districts. We provide advisory services, which is essentially consulting work to some of these project teams. And then recently we launched a certification platform to recognize leading projects. This is our way of formally recognizing eco-district projects, and it also includes an accredited professional program. So our work is all based on what we call the EcoDistricts protocol. This is really our theory of change, or our model for neighborhood development. It includes 3 key imperatives around equity, resilience, and climate protection, 6 key priority areas, and then perhaps most fundamentally is our implementation steps around formation, which is really about creating a governance and decision-making structure in a community, developing a roadmap or a plan, for EcoDistricts implementation, and then ultimately about tracking performance improvements over time. So with that, I am pleased to turn it over to Scott Bernstein and Jen McGraw. They are both with the Center for Neighborhood Technology. Scott is their founder and now Chief Strategy and Innovation Officer. Scott works to understand and better disclose the economic value of resource use in urban communities. He was appointed by President Clinton to the President's Council for Sustainable Development and has contributed to a number of federal panels on climate change, development strategy, and science. Jen McGraw is the Director of Sustainability Innovation. She leads strategies to promote district-scale infrastructure innovation and has worked in the areas of urban sustainability around climate change, transportation, TOD, energy, stormwater air pollution, and household cost of living. She was also a member of our EcoDistricts Protocol Advisory Committee. So I'm happy to turn it over to Scott to start.
Well, thank you very much, Naomi. Thanks to the whole EcoDistricts team for making this possible. We're going to present some of the findings of work we've done over the last couple of years to better understand how district approaches to the provision of what's often thought of as infrastructure can produce a wide range of benefits to communities, and in particular, why doing those in an industrial context that make a lot of sense. This work was made possible by an anonymous donor and by a group called Fund Change, and I want to add my thanks to those supporters as well. If you look at this picture in the title slide, it says in archaic script, Central Manufacturing District, Union Freight Station. This was the corner of a 1-mile square sprawling complex that housed 200 companies and 40,000 jobs. That's right, in 1 square mile. The world knew half of it, the Chicago Union Stockyards, but the other half of it was really America's first eco-district. The people who developed this saw that for small companies to meet their aspirations of becoming larger ones, they needed to operate efficiently. So in this one district, you had 100 years ago and more, combined heat and power, central provision of stormwater management services, sanitation, planning, engineering services, a bank to provide working capital and credit, one of America's first effective workforce development programs. And you also had the ability to aggregate small shipments into entire freight car, boxcar loads to keep the cost of transportation affordable. And with that, growth could happen. This wasn't a one-off. It was copied all over the country. And it has many of the elements we're going to talk about today. Could I have the next slide, please? So why industrial eco-districts? Well, one answer to the why is that the manufacturing sector uses a lot of the resource that we consume in America. On average, the consumption of energy in the United States, 20% of that is for manufacturing, but in manufacturing centers such as Chicago, it approaches 1/3. And there's similar numbers associated with the resource, the energy, and the money needed to handle water and transportation and land. And a second sort of reason is that industry is organized at multiple scales, and we could be talking about action that happens at the scale of an individual building or a block, action and economy that happens at the level of a district, which could be a neighborhood, or it could be a semi-invisible district, such as one served by an electrical substation, or it could happen on a citywide sort of basis. An example of something that happens at the scale of a building or a block in Chicago is a shared use facility known as the Fulton Carroll Incubator, America's largest startup incubator for small manufacturing businesses. At any point in time, in a single building with 500,000 square feet, there's 50 to 100 companies operating with 600 to 900 employees. This has been so successful over its 30-year period that they're branching out now with a special focus incubator on food companies and the startup resources that they need, and figuring out how to do this as efficiently as possible occupied a lot of time of a lot of people. Both of these examples, the Central Manufacturing District and the hatchery, are documented in publications with those words in it. If you go to cnt.org and click on publications, those can be yours too. So how do we right-size our approach to making manufacturing and industry efficient? And how do we do it in a way that throws off not only company benefits but community benefits? And how do we do this in a way that could grow to scale? And is there a way to do this in cooperation with existing larger institutions who we think of as responsible for providing energy or water or transportation? Next slide, please. So one way is by thinking of this as integrated infrastructure, things that produce multiple benefits for single investments. But if you look at these two pictures, you have two very different worldviews. The one at the top is in a 500,000 square foot building that does warehousing and some manufacturing. It looks like it's some sort of automated shelving and distribution system, and that's exactly what it is. It makes intense use of space in 3 dimensions on that 500,000 square foot floor plate with 42 to 48 foot ceilings. But it's kind of hard to imagine small companies fitting efficiently into a space like that. By contrast, the picture on the bottom, which is an artist's image of something that has started construction in the San Francisco Design District, known as 100 Hooper, is a set of buildings designed to offer the kinds of incubator spaces that you might imagine are worthy of the name EcoDistrict. Super efficient space, efficient use of resources, as close to zero waste as they can get. And notice I said the design district. This isn't fitting into your grandfather or your grandmother's industrial park. This is fitting into high density San Francisco mixed use urban form. Because industry today, unlike industry in the past, isn't smoky, isn't nearly as noisy, is very labor intensive, and can use space efficiently as a result, and therefore is appropriately urban. Next slide. So to make this work, you have to, as usual, be able to make the case that there are benefits to doing right-sized industry over business as usual. One is that there would be reduced operational costs for, if not going it alone, providing supplemental district energy resources or district water resources or on-demand transportation or smarter approaches to receiving inputs and shipping things out. Secondly, you'd have to be able to show that the systems that result in the overall situation from a business point of view would be more resilient, that it wouldn't be as susceptible to the disastrous results of an electrical outage, for example, or of unexpected weather events. The third is that they could operate with a lower environmental impact, both in terms of criteria pollutants as well as in terms of greenhouse gas emissions. A fourth is that the equipment that would be designed would be there to meet special production needs, perhaps even involving tailoring the waste streams of Company A to meet the input needs of Company B. In the case of those food companies, we have wonderful on-site opportunities to do that kind of matchmaking. The next is that these savings would all add up to something significant enough to make these businesses more competitive, and there's a subtlety there. You not only want to be more competitive when you're a startup, but as you graduate from, let's say, an incubator space into full production mode, that A, you're more likely to go into production than simply selling the idea, and B, that you've worked with other companies or realtors nearby to make sure that there actually is space available to graduate into, so it's successional. And finally, you'd have to meet real-world external policy requirements. Next slide. So before I turn it over to Jen, I want to explain these two cryptic triangles here. These are a result of a study we did regarding public investment in transportation, where we asked two kinds of stakeholders, why do you invest in transportation? What are the economic benefits of the mammoth investments that are made? The triangle on the left shows the rough results of what happened when you ask that question of people in charge of economic development outcomes for state departments of transportation. They were overwhelmingly focused on systems benefits, such as the condition of the system itself and why it's worth it to keep it up, on safety and on connectivity, and overall on free flow of traffic. Community benefits, per se, hardly entered into any of their answers. When we asked the same question of local elected officials or people in charge of metropolitan planning organizations, the results look more like the triangle on the right. The answers were about regional and local economic development, cost of living reduction, the benefits to the supply chain, the tax base yield, permanent jobs instead of temporary jobs, and increasingly livability. Well, eco-districts as an approach are more about the second triangle than the first, but they're also about conforming these two worldviews. So again, cnt.org, click on publications, you can see what we found. It's my pleasure now to turn the mic over to Jen McGraw, who has been many things at CNT and has been leading our work in showing how to make eco-districts work with an industrial focus in urban areas. So thank you, and Jen, it's yours.
Thanks, Scott. So one of the things we've been doing is doing a lot of learning about best practices around the country and around the world that we think could be applied to an industrial eco-district. Now, some of these are not yet at scale, and some of these are being applied more in a residential or commercial setting, but we think they have a lot of potential as manufacturing starts to come back to urban areas. And manufacturing really is growing in the U.S., and cities have to be ready to bring manufacturing back to their neighborhoods. And one of the ways to do that is to have sites that have the best infrastructure possible for manufacturers to be competitive and to achieve all those benefits that Scott was just talking about. So the first area I'll talk about is energy, and I have a lot to cover here, so I'm going to go through pretty quickly. And I know we have a really diverse set of folks on the line with a lot of knowledge, so please do type in a question or comment. We'd like to have this be a little bit more of a discussion, so don't hesitate to do that. So the first thing we looked at was renewables and storage, and we put those two together because storage capacity is getting better and better, and renewables generally don't operate 24 hours a day, with some exceptions. So the two really need to go hand in hand. And the cost of doing that is getting more and more cost effective. So in 2016, estimates for PV are about $2 million per megawatt. And what that gets you is reliability, energy independence, a low carbon footprint, and even some brand benefits if you're a manufacturer that's solar generating. The second strategy we looked at is district energy. So district energy is not new. It's a system that provides heating and cooling to a set of buildings. This can be through steam heat or chilled water. And there are actually a lot of district energy systems around the world, fewer in the US. The biggest one is in St. Paul, which provides heat to about 300 residential and 200 non-residential buildings. And this can provide cost benefit, again, some energy independence benefits, environmental benefits, but even more as systems are starting to look towards biomass as one of the fuels. The older systems have been very fossil fuel based, which can be a lower environmental benefit. And it can be made a lot more efficient with the modern technology. So the cost here can be really substantial upfront cost. There's a system in Boston, Cambridge, that required over $100 million upfront, and they were actually using part of an old mothballed system, and expanding on it. So this is one of the systems that big benefit, big upfront cost, and requires a real commitment to a district scale solution. But there are a lot of mothballed systems out there that we've found. If you look at the EPA's eGrid database, that can be a great starting point, sort of a hidden asset for cities to build on. Microgrids are a hot topic in the energy world. They're basically just an electrical grid on a smaller scale. So it's a set of users, some controllers, a power source, maybe a bank of batteries or a backup generator. And folks are doing this for reliability and efficiency, power quality needs, and sustainability. So on the East Coast after Hurricane Sandy, microgrids became a very popular topic because the resilience potential of microgrids can really get folks through a storm where the larger grid goes out if the system is designed so that it can be islanded from the larger grid. Now, again, the cost of these are pretty substantial up front. We looked at case studies around the country and found an average of about $3 million per system with a range from $1 million to $9 million. But at the high end, those were combined with combined heat and power systems, so they were providing some thermal benefit. So the cost needs to consider all of the benefits that the system is providing. So it might be cost effective even if it seems very expensive up front. The last energy system that we looked at is the old workhorse of energy efficiency and demand management. Energy efficiency really is the starting point of any of these. So the less energy you require to use, the less you'll need to invest in to handle the supply. And we recently did a study that Scott mentioned of the hatchery, so that food incubator system that's being developed in Chicago. We worked with Navigant, and we did an energy assessment of the potential for saving energy in a manufacturing incubator like that. And food systems are very particular for their energy efficiency needs. So there's ventilation, there's cold storage, there's, all types of burners and hoods. And I think it's a good example. I encourage folks, if they're interested, to find our paper online on that, because it shows you that the context is really important in terms of when you're thinking about the energy efficiency potential. But one of the other findings was really that the people are one of the most important systems for energy efficiency. The folks in the building are making the choices of when to start up equipment, when to turn it off, and their operations decisions and even their innovations are part of what is going to make the system work and continually improve. Now, ACEEE has found that energy efficiency is the least expensive energy source in the country at 2.8 cents per kilowatt hour. And it's important because energy can be as much as 10% of a production cost for a manufacturer. So figuring out ways to cut that cost can improve competitiveness. And I could go on and on about energy efficiency, but we didn't just look at energy efficiency. We also looked at water efficiency, which if my slide will change, I'll show you. And the issues on water efficiency are very similar. So when you're designing for energy efficiency, you need to be thinking about water too. And we found that the best practices out there are really figuring out ways to not just change operations, but change equipment design, change even design practices to reduce water demand and create efficient water use. But water reuse is really where a lot of the innovation is happening. And water reuse is not new to industrial practices. It's been around for many years, but the demand for it seems to be growing in part because of the increasing cost of water and water treatment, and because the technology is getting better. So we found one great example of a Frito-Lay factory where they're actually taking the water that they use to wash the potatoes and treating it on site and reusing it on site. And as a result, they're not holding wastewater on site in a big pond, and they had additional land available, which they then turned into a space for solar. So it was sort of a triple win. I'm not sure of the pure cost effectiveness of that, but they're certainly getting a lot of benefit from it. And in an area where water is scarce, that type of on-site reuse is extra valuable. And, you know, a water reuse system can range from as little as, you know, 10 cents to as much as $3 per 1,000 gallons, as we found. But the benefits can accrue over decades. And like we said, you know, studies are showing that the cost of water is going up and up, and finding ways that a manufacturer can reduce its demand on municipal water really creates benefits for the whole community. So the next kind of infrastructure that we looked at is transportation. Now, this is right at CNT's heart to think about transportation, not just a matter of getting people to and from somewhere, but thinking about the place as a whole. So the picture here is of the Heath Ceramics Factory in San Francisco. And what I like about this picture is that on the bottom right corner, there is a car share car. So that car is actually in a reserved city spot, and it's always available for car share members to use. But this site is also transit accessible. It's connected to the bike network. And what's going on in the building is there is a ceramics manufacturer. There's a retail store for their ceramics. There's a coffee shop. There's a restaurant. There's offices. And there's an art facility. So this really required what the city once described as zoning yoga to make happen, because this is a traditionally industrial space, and so incorporating all those other uses took some effort. But it's the real hub of the neighborhood and an example of sort of the modern manufacturing as community center. And the Heath brand is very popular, kind of high-end, and I think having this sort of made in California brand has really benefited them. But transportation location is essential for not just attracting customers, but for the workers too. And CNT's All Transit database is a tool that you can use to enter an address and see how many people can access that site in 30 minutes on transit. And you'll find in the typical, you know, exurban areas where industrial parks are being developed, there aren't very many workers or customers who can access that site on transit. And in an urban area, the workforce pool the employer has access to just expands exponentially. And so even though urban transit-served locations are typically more expensive on a square footage basis, the benefits may pay off, and it's worth thinking through how those benefits accrue before making a decision on pure square footage cost. One more thing I'll say about this is that, you know, finding urban industrial space is getting harder, and there's competition for these spaces. And so it's important for cities to think about protecting these spaces. We all love a shiny new loft condo, but if a place that's going to be able to employ, you know, 30, 50 people or more is being turned into a couple of units of housing, that's something to think about in terms of trade-offs. And protecting industrial space is an important part of the policy environment. The second transportation type that we think about is getting goods to and from the manufacturing space. So the transportation of raw materials and finished products is a piece of infrastructure, and typically rail access has been considered sort of a smelly, loud, dirty relic, but in fact, manufacturing and freight facilities are really an anchoring function for local and regional economies. And the modernization of rail that's happening is making it cleaner, more electric, more compact, and in fact, new technologies are allowing cargo containers to be moved faster, organized better, so there's more space on rail yards, and you can actually bring manufacturing to rail. And this is important because, as this slide shows, small firms can pay as much as 14% for shipping compared to a large manufacturing firm who can pay 3%. So if you think about it, a small firm that's using FedEx or UPS, they have on-demand service, it's very convenient, but it's really eating into their bottom line. And finding ways that they can access these more efficient, more cost-effective solutions like rail are not only cost-effective but have environmental benefits. Unfortunately, the railroads don't want a bunch of small UPS-sized boxes. So an intermediary that aggregates up to the rail car size is really necessary to make this work on scale. And lastly, I want to talk a little bit about waste as an infrastructure system. So manufacturers are using supply chain management, quality control, and smart design to cut waste. In the 1990s, there was a big effort to look at eco-industrial parks to figure out if one company's waste could become another company's input. And in fact, the picture that you're seeing is an example of that kind of work being done today at the plant in Chicago, which is a really innovative facility that is showcasing many closed-loop systems like that. So they have a brewery on site, and the brewers' grains are being used to feed fish at a fish growing facility, which is then being used to provide a bunch of other systems to the building. And I really encourage you to look at their website. They have some really great, interesting things going on. But in general, the waste solutions that are being pursued are being done by companies themselves. So figuring out, rather than linking a bunch of companies together, but internal to the company, what can we do? And compost, recycling, material reuse are actually much more job intensive than pure landfilling. So there's job creation potential here. And when you think about the potential of anaerobic digestion, which takes organic waste like food and makes heat or other energy for the building out of it, this is actually a way to take a waste product and make it be, working for the bottom line of the organization. So reducing not only the cost of waste disposal, but the cost of energy bills. And I think there's a lot of potential going forward with that. Anaerobic digesters can cost as much as $300,000, but they have potential to save, tens of thousands or more a year on waste disposal and energy. And so for some organizations, that can really pay back quickly. And I think it's something that is being designed more and more for this type of building and something to think about. But that requires some policy changes, likely on the local level, to make sure that it works, which is the last thing I want to talk about, which is getting it done. So when we think about where a potential eco-district can work, we think a lot about site selection. So not only the transportation assets at the site, but clustering, other industrial users or users that could benefit from having district scale infrastructure nearby, such as an institution like a hospital or a neighborhood that is willing to get involved in the eco-district model. So site selections is essential. And as Naomi discussed, eco-district has really focused on governance and engagement. So taking this big spaghetti noodle group of actors at the top of this slide and figuring out how do you make them work together, who owns the building, who owns the resources, how is it managed, how are we paying for this, and thinking about that upfront, before you even get into it, is really important, because different models will have different benefits of financing. So a nonprofit may be able to get philanthropic financing, a local government may be able to get federal money, but neither one of those is going to be able to get private equity that expects a return per se. And we could go on and on about the financing issues, and in fact, we've written a whole separate paper on that. So if you have questions, please do ask them, and we can talk about more. We think there are a lot of opportunities out there to take some new financing innovations and apply them to this model to try to get over the hump of some of these upfront capital costs and some of the undervaluing of the benefits that the market's currently doing. In terms of policy, like I was saying, local governments have to do the work to make these sites viable. A lot of what we've been talking about may not be technically feasible under current zoning or utility regulations, and that takes effort on both the regulator and the implementer side to work together to make the solutions happen. Often regulators want to let this happen, but it's just older policies have not caught up with the new innovations. And part of the way to get there is by documenting the benefits. So showing the benefits to the community of doing these things can really get you a lot of the way there in terms of attracting financing and solving the policy conundrums. So with that, I'm going to say thank you, and we're publishing a publication on this any day now. It's in the design process right now. So if you go to this website, it'll be there probably next week, but we will also send it out to anyone who's registered for this webinar. And at that cnt.org/publication site, you'll find the other publications we've been talking about. And furthermore, if you have questions or follow-up, please do get in touch with Scott or I. We're happy to talk about this stuff on and on. So thank you for your attention, and I want to hear if anyone's had any questions.
Great. Thank you, Jen and Scott. So please, as you have your questions, feel free to type them into the question box. We've had a few that have come in and look forward to a good follow-up discussion. So the first one is, what are some of the financing innovations that you looked at? Jen was alluding to them in your last slide.
Sure, I'll get started here. The innovations come from an analysis of what the current barriers are. Overwhelmingly right now, district level systems for energy or for water or for combinations of energy and water and transportation materials are being provided by vendors. The first problem that comes in is similar to the problem you have if you're trying to assemble a home entertainment system or build your own computer. If the equipment's coming from different vendors, there is no single point that you can count on to assemble all the different pieces of financing. So the first innovation we're looking at is a one-stop shop where a project sponsor could get an honest audit of the opportunities, benefits, and what needs to be done to achieve them. The second is financing that's tailored to seeing the investment as a system instead of as a separate set of systems being done for different purposes. And the third is access to contractors. And the fourth is some scorekeeping to go along with this in the interest of continuous improvement. Another is examining ways that rating protocols, such as the lead rating systems or the EcoDistrict protocol, could be used as a way to ease the underwriting barriers to counting the benefits of that come out of these integrated sorts of systems. And then a third is identification of EcoDistricts as an asset class, something that the wholesale markets could agree to invest in that would make it possible then for individual lenders or even community development financial institutions to be able to specialize in this, knowing that the loans that they make might be insured, there could be a secondary market for it, much as there is for housing, and with those kinds of backstops, much of the barriers that we look at disappear. The fourth thing that we looked at were policy barriers, and that's a longer discussion that we can have today. But as long as in most jurisdictions it's pretty close to illegal to resell electricity, for example, it becomes hard to optimally design these systems. So we're looking at some policy innovations that could be implemented at the local level to make that happen, perhaps written into the franchise agreements that are granted to utilities for the provision of energy.
And I would add, there's a whole set of capital out there that's starting to recognize the benefit of non-financial returns. So green bonds, environmental impact bonds, social impact bonds, resilience bonds, and even mini bonds where neighborhoods can invest in their own infrastructure improvements. And so demonstrating this sort of double bottom line benefit in ways that the market and market actors can count on and expect return on is something that I think needs to happen. And I think that there's a lot of examples out there of people making it happen. So I think that it has a lot of potential.
Great. Thanks, guys. So a few questions about specific examples. So someone asking about local examples of accelerated eco-district concepts, and maybe combining that with a question about leading project examples where many of these strategies that Jen talked about are integrated in one place. Are there kind of some shiny examples out there that folks can follow up on?
Well, in terms of sites labeled eco-district, I think, Nami, that might be a better suited question for you. And one of the things at C&T that we've been looking at is because there aren't yet that many eco-districts per se in the U.S., like what are the barriers and what are the places where pieces of it are successful? So that's why when we talk about a place like Heath Ceramics, that is not a district yet. It's one block or part of a block, but we see it as a piece of the puzzle. And we think that this industrial piece has been a little bit left behind. In some cities, manufacturing became very old news, and now it's coming back, and we really need to think about what is the 21st century version of this and how does it work for neighborhoods.
I would encourage people to look at the results of the recent competition run in the state of New York by the New York State Energy Research and Development Authority, which rewarded financial support to leading designs that are intended to be implemented for microgrid applications. The applications range from industry to campuses to standard mixed-use development, and we were very impressed with the quality of the competition and the use of a competition as an incentive to actually get accelerated action going. Some of the best practitioners that are out there aren't in the industrial sector per se, but rather are the 2,000 or so eds and meds or colleges and medical centers that have shared resource facilities such as the ones we're talking about. And those are important to not forget about. The excitement is about, at the moment, things with labels like smart grid and Internet of Things and microgrids. Microgrids, total microgrid deployments last year were on the order of $1 billion. You might be able to push it to $2 billion if you looked at some of the associated investments. Estimates of the deployment of combined heat and power, or cogeneration, by contrast, range from $20 to $35 billion. So I would look for where there are some of those shared facilities. We were able to identify a number of breweries around the country who were interested in saving energy, but were equally interested in making sure that their own water quality was sufficient to guarantee product quality. So while a number of those pop up in California and in Colorado, I think Fat Tire is one of them, New Belgium Brewery. Flint, Michigan was one of them too. The startup brewery there decided not to go out of business in the wake of the water crisis, but to invest instead in their own water treatment system. And I guess finally I would add to that particular list, you may have heard the phrase water-energy nexus or energy-water nexus. This refers to the fact that the two largest municipal uses of energy are likely to be for pumping water and pumping drainage, whether that's stormwater or sewage or other waste products. And the ability to actually take these municipal or public enterprises to the next level, I think, is one of the opportunities that's about to pop at all the scales that we're talking about here. So while it's hard to find a 21st century industrial park today that has all of these features, I'd say we can point you, if you ask about an area of the country, to places that have some of these almost everywhere.
Well, and that reminds me, Scott, that example that you visited, the Murphy's warehouse in Minneapolis, where they are treating all of their stormwater on site and saving all of their stormwater funds.
Yeah, he's pretty.
Do you have more to say about that site?
Sure, this guy's pretty sharp. Third generation. Murphy's warehouses started out as humbly as it sounds. He's about the best supply chain manager that we've run into. It's a 20-acre former industrial complex of buildings that he put to reuse, first as warehouses, then as what's called third-party logistics, which means that while he's providing advanced shipping services, he's also providing, in a job shop sense, intermediate fabrication and manufacturing services to go along with that, as well as renting out space to other producers. He has solar PV on the roofs to cut his peak energy load. He's planted the whole thing to keep all the rainwater on site. I think he started out 10 years ago saving $50,000 a year. It's now $70,000 a year. He locates all of his facilities like this next to rail yards of one sort or another, either the very large integrated industrial park scale rail yards or very small ones that are known as transload facilities that allow for the quick transfer of product to get that savings that Jen was talking about. And he arguably is the only such facility in the United States to achieve LEED Gold rating. So he's operating a mini eco-district there with his company, and it's worth knowing about and highlighting.
Great. So we have a few questions about scale and how this applies to eco-districts and the eco-district protocol. So I can maybe take a first crack at that and then let Scott and Jen jump in. So in terms of scale, you know, we haven't defined a minimum scale for eco-districts. You know, the idea is really that there's more than one stakeholder involved, and that's kind of the smallest scale. But I think from our experience, it's you know, about 10 acres is probably the minimum, and we're working on projects all the way up to several thousand acres. So just to give you a sense of scale, but you know, as Jen mentioned, the Heath warehouse, you know, is one example of a building, and I think the application or where it intersects with the eco-districts protocol is really thinking about, you know, the opportunities that CNT has identified here for the building and an industrial service or environmental service that it provides to do something that serves more than just its own footprint. So the example of a district energy system that could also provide heating and cooling to adjacent, you know, residential properties, for example. Or one of our first projects pursuing eco-district certified is the Atlanta airport, and they actually see eco-districts as a way to engage their partners and stakeholders at the airport and who, you know, do business with them around a more integrated conversation around environmental performance. And so to that piece about sort of governance and engagement, it's a way for or an opportunity for, in some cases, an industrial facility or a large company to engage with its broader market in a different way and provide that sort of decision-making or engagement structure to do that. Do you guys have more feedback on that, Jen or Scott?
I do. Let's start out at the large scale and work our way down to something more tractable. We presented last year the work that a team of us did, CNT and an organization called Placemakers, for the city of Phoenix to build an eco-district to cover a 2 square mile area centered around the 2 transit stations closest to the Phoenix Sky Harbor Airport. They needed a solution in Phoenix as to how to pay for the infrastructure to grow out around those stations, since they were built on former highway right-of-way and had never had infrastructure to take on dense mixed-use urban development. And that is working its way through the system and is written as a goal to build such a system into the comprehensive plan for Phoenix, and known as Reinvent Phoenix. Working our way down, there was a word or a phrase invented for the kind of facility represented by the Central Manufacturing District when it opened up in 1902, and that phrase was industrial park. It meant a clustered area dedicated to production with the specialized infrastructure, especially rail, that was needed to keep the cost of operation down so that capital could be invested and growth could happen. And as I mentioned, that grew to a 1 square mile facility with 40,000 employees at peak. At the scale of a block, you mentioned 10 acres or more, Naomi. Interestingly, the typical city block in America in the most densely occupied parts of our cities ranges from 2 to 5 acres. In most centrally located urban neighborhoods or town centers in first ring and older suburbs, you're looking at something like 9 to 10 acres. That's a lot of room. And I don't know how much space 100 Hooper is occupying, Jen, as a footprint, but my sense was it's less than a block. I mentioned the block that the Industrial Council of the Northwest Community used to build out the Fulton Carroll incubator from a former plumbing supply company, 500,000 square feet, but the footprint neatly goes to the lot line of probably a 5-acre block. So, you know, you can do these things at a number of scales. Of course, you can do them differently. You can take a neighborhood as is and look at joint investments in a particular technology set. That's what happens with so-called community solar. The way that's being implemented in Chicago is that community solar is being implemented as a co-op that property owners can invest in together, and rather than have to negotiate a good buyback rate with the local utility, people get paid in lieu of that, the equivalent, a shareholder's dividend. And there's other ways to arrange those sorts of activities as well. Jen also mentioned mini bonds in Denver. A very small neighborhood of 5 or 6 blocks needed to replace plain vanilla water, sewer, sidewalks, and do some tree planting for a total cost of $17 million. The city said, we're not going to hold another bond sale for 5 years. And the community came back and said, what if we bought the bonds? And so they tried an experiment on the internet. They had an auction. It was only going to be open for 1 week. The opening bell rang at 8:30 on the internet on Monday morning. Instead of a week, the whole issue sold out in 12 minutes. People bought the bonds themselves. The relatively low interest rates that 3 to 4% that a city gets for municipal bonds look pretty good as a return compared to the 0 to 1% most of us can get today on our savings accounts. So there's a complicated dance, I think, between scale, technology, financial feasibility, and how to get the right permissions to put this together. You know, to take this to scale will require, I think, the same sorts of skilled intermediaries, one-stop shops that we helped build out starting 30 years ago to serve the building retrofit needs of urban neighborhoods. Now I think it's time to take that to scale with infrastructure as well.
I think the other important piece to consider about scale, and Scott was starting to get at this, is that each system is inherently going to have its own natural scale, right? A district energy system is going to follow where the demand and the load is, and similarly for a water system. So, within a broader eco-district geography or eco-district boundary, if if a community is pursuing a number of strategies, each one might have a slightly different boundary.
I think that's right. I think we're also pushing the boundary this year in particular because of the live discussion about crumbling infrastructure. If that discussion went on without there being some more decentralized alternatives or distributed alternatives with integrated outcomes, if somebody figures out how to push the button to spend trillions of dollars just replacing what we have, what we'll get is brand new state-of-the-art 1920s infrastructure networks and all the problems that they helped create. So putting these neighborhood scale initiatives into context, people have shown already because of the work of EcoDistricts.org and others that they're willing to put in the time to get organized to explore more efficient ways of using resources. The time is pretty good right now to figure out the answer to the question, how do we do that with the more tangible infrastructure networks that sit invisibly usually below where we're standing or sitting, and do that in a way that's sustainable. And as Jen mentioned, the economics are finally looking really good for this. They look good enough for individual buildings and companies to do, and they're starting to look good enough for clusters of enterprises to work on as well, and the benefits look fantastic. So I think that's where we're at.
Great. So let's see. I think we have time for one more question. I'm sorry we're not going to get to all of them, but someone is asking about planning or policy concepts that are being tested or potentially in place that allow a more integrated geothermal storage EV charging system within some of these industrial eco-districts that make it easier for adjacent neighborhoods and businesses to plug in. Any examples there that you guys found?
I think that, yeah, when you're dealing with vacant and formerly industrial property or property that was otherwise aggregated, perhaps owned by a public agency and the land is already integrated, it becomes easier to make the case that each user isn't a separate customer, and that's one way to get around the pushback from legacy utilities and others that these systems are simply taking their customers away. Other strategies, on the other hand, in more enlightened jurisdictions involve partnering with utilities and water suppliers and others so that there isn't any conflict around that. In San Francisco, there's a very innovative piece of zoning known as PDR, which I believe stands for production, distribution, and repair, to allow those three functions to coexist with more standard commercial and residential activities in a mixed-use kind of setting, and that kind of extreme mixed use should be encouraged everywhere. Finally, I would take a look at your own jurisdictions to find out if so-called form-based codes have been implemented or are being considered, because they do represent a time to redo and overhaul and simplify and remove barriers in your current zoning codes, which were largely written to prevent the mixing of different uses of adjacent properties. And it's the time to start to address infrastructure explicitly as the kind of thing that could cross those property boundaries, whether it was for the technologies named or for any of the purposes that we talked about today. So I think there are policy innovations out there. I mentioned in passing that all utilities need franchises from their local governments in order to be able to operate, and those come up every so many years. That's the right time to start to raise new provisions within such a franchise, which is a license to operate, that allow you to do things like cross property lines and streets and alleys and connect to poles together. That sounds terribly boring, but that's what those franchises do. And those rights are currently typically guaranteed to single providers. And if you don't make those sort of reciprocal with the community, then you're giving away the opportunity to fulfill the vision that we've been talking about.
Great. Well, thank you, Scott and Jen, so much, and thank you to all of us for joining us. I'm sorry we didn't have a chance to get to all of the questions, but I just want to make a quick plug. If you're energized by these topics and would like to discuss them further, I'd encourage you to join us for our EcoDistrict Summit in Atlanta this fall. If we didn't get your question or you have follow-up thoughts, any of us would be happy to chat with you, and just feel free to send us an email to continue the conversation. So thank you so much, and have a great rest of the day.
Thank you, Naomi.
Thank you.